Now let us discuss one example of Norton's theorem. So problem statement is find Norton equivalent circuit. If this is a simple circuit shown, one current source is there, one voltage source is there, and here at this open end side we are supposed to find out the from this direction we have to look into the circuit, and we are supposed to find out Norton's equivalent across this terminal. We want to apply Norton's theorem. So first step is in Norton's theorem, we want to find out Norton's equivalent resistance, that is Rn we will call, since here all are resistors. So for that purpose, as per rule, whatever is a current source in the circuit, that is to be removed by just open it and remove. Voltage source, if it is, then it is to be replaced by internal resistance, but if it is not mentioned, then directly short that particulars, that is assume internal resistance as 0. The circuit will look like this. This part is open, then this is shorted, so therefore it is looking like this 4, this 8, this 8 and this 5. Now you will see just that you may assume that all of them are as if coming series, so it is not like that. First of all, here it is open, so Rn we are from this side, we are like from this side we are seeing through and looking into, and then we want to calculate. Then this 4, 8 and 8, since here it is removed, so all these 3, 8, 4, 8, all these 3 will be in series. So therefore effective resistance will be 4 plus 8 plus 8, that is 16 plus 4, that is 20. See here, remember, from this side we are looking back. If from other side we are looking back, then 5, 8, 8 would have become in series, and that resultant will become in parallel with 4. But now the situation is we are supposed to go to the other side of the circuit, that end, and from that we are starting the calculation. So from this side if we calculate, then 4, 8, 8 all 3 are in series and the resultant is in parallel with 5. So 4, 8, 8 total will be 16 plus 4, that is 20. 20 is in parallel with 5, that is 20 into 5, 100 divided by 25. So resultant will be, this is 4 ohm. 20 into 5 divided by 20 plus 5. So that's why resultant is 4 ohm, that is your Rn. Now for finding short circuit current, wherever you have like you are from which the terminal from through which you are looking back, that those terminals are to be shorted. So here it is a short circuit. So we want to find out current coming to this direction. Resultant circuit will look like this: 2 ampere as it is, this particular battery as it is. Now this 12 volt and 4 ohm resistance we can just replace by current source, and rest of the things, first of all this 5 and parallel with short circuit path, that is 0. So 5 parallel 0 is 0, nothing but, so therefore this is removed, only 8, 8 and this 4 is remaining, and this 12 volt supply and this 2 ampere current. Now what we will do is this 8 plus 8, 16, and this 16 will be coming in parallel with 4. So like that we will write 16 parallel with 4, and that is to be driven by one voltage source of value 12 volt. Now what we will do, we will change this voltage source, because ideally it is voltage source in with series resistance, that is the ideal practice. So that is converted into current source. So it is 12 volt divided by 4 ohm, that is 3 ampere is a current source, and across that is parallel 4 ohm resistance, and parallel to this 4 ohm there is appearing 16 ohm resistance. So current will be 2 ampere, 2 ampere, both are in upward direction, so total 5 ampere, and resistance will be 4, and one more resistance is of value 16. Now since we want to find out current coming towards this direction, that is as if short circuit current, that is nothing but Norton's current, and that is coming as an IN. So for coming derived from IN. So for example here now it is 2 plus 3, 5 ampere total current. Now short circuit current will be other resistor is 4 divided by in circuit resistances are 16 plus resultant, when it is in you are in 16 plus 4. So 4 divided by 16 plus 4, that is coming 20, and this 20 divided by 20, it is coming 1. Short circuit current will be 1 ampere. So this is Norton's equivalent. You can see once again these many like resistors are there. First of all we have to remove this 2 ampere open circuit, 20 volt short circuit, and we are finding equivalent resistance. So equivalent resistance is coming 488. All these three are in series. From that other side, if we look into the circuit, and that resultant is in parallel with 5. So 488 is coming 16 plus 420, 20 parallel 5. The answer is coming 4 ohm. And for short circuit current, we have shorted this, and therefore 5 parallel 0, that is also giving you the 0 resistance. So that is to be considered, that is as if 0. And now the remaining part is you can apply directly this current source conversion, voltage to current source converted. 2 plus 3 5, and 4 and 16. So current division rule we can apply. So here it is, short circuit current is equal to other resistor, that is 4 divided by 16 plus 4 into 5. So this is coming out to be short circuit current 1 ampere.